StemScopedia, 7th grade, Structure of Matter. Our world is full of various substances we call matter. Matter is anything that takes up space, volume, and has mass. Take a look at the picture on the right. What kinds of matter do you see? The cars are made of solid matter, like the metal frames and glass windows. Cars also need liquid matter to function, like gasoline for fuel and oil for lubrication. The exhaust coming out of the tailpipes is matter in the form of a gas. The metal, glass, gasoline, and exhaust are composed of many different types of matter. For example, metal car frames are typically hard steel made from the elements iron and carbon, while the glass is a compound made of silicon and oxygen. The exhaust is a mixture of gases such as carbon dioxide. There are more than 100 different elements, each with its own type of atom. These atoms are the tiny particles that serve as building blocks of all matter. A bar of the element gold contains many millions of individual gold atoms. An atom is the smallest particle of an element that cannot be broken down without changing the properties of the element. One atom of gold is very small, too small to be visible. However, a single atom of gold has the same properties as every other gold atom. What are atoms made of? Do all atoms have the same structure? All atoms have the same general arrangement of subatomic particles with protons and neutrons in the nucleus or center of the atom, surrounded by a cloud of electrons. Scientists refer to this structure as the electron cloud model of an atom. Look out, oxygen. The electron cloud model of an atom is more accurate in its depiction of the electrons than older atomic model developed by Niels Bohr in 1913. Bohr's model described electrons as orbiting the nucleus in a flat plane like planets in our solar system. In the electron cloud model, the nucleus is surrounded by a negatively charged electron cloud where electrons travel in high probability areas called orbitals. Both models describe a dense central nucleus composed of positive protons and neutral neutrons. Reflect. The location and charge of subatomic particles determines structure. Protons, neutrons, and electrons differ from each other in their locations in an atom and their electrical charges. Electrical attractions and repulsions between charged particles, i.e. atomic nuclei electrons, in matter explain the structure of atoms. Protons, shown as red spheres, are positively charged particles found in the nucleus of an atom. Since protons are the only charged particle in the nucleus, an atom's nucleus is always positively charged. Atoms of each element contain a characteristic number of protons. In fact, the number of protons, or atomic number, determines the element. For example, all nitrogen atoms have 7 protons, and thus an atomic number of 7. Sulfur atoms have 16 protons, while iron atoms have 26 protons. Neutrons, shown as yellow spheres, do not have an electrical charge. They are neutral. Neutrons are found in the nucleus of the atom. Electrons, shown as blue spheres, are negatively charged particles. They travel within the electron cloud surrounding the nucleus. Electrons are constantly moving at nearly the speed of light. The Bohr models above simplify the arrangement of electrons and emphasize the energy levels, which influence how the atom can react with other atoms. Atomic mass and volume. Each proton and neutron has a mass of approximately 1.67 times 10 to the 27th kilogram. The mass of one electron is has a mass of approximately 1.67 times 10 to the negative 20 to the negative 27 to the negative 27th power. Well, that's difficult to say. That number is actually quite small. The mass of one electron is negligible at 9.11 times 10 to the negative 31st kilogram. Almost all of an atom's mass is located in the nucleus. Atomic mass is the average mass of all the protons and neutrons in an atom. The average atomic mass, where P equals number of protons and N equals number of neutrons, is P plus N. The unit for atomic mass is the AMU, atomic mass unit. If an atom has 3 protons and 4 neutrons, its mass is 7 AMU. Electrons are so small that they do not make a significant contribution to the mass of an atom. The nucleus of an atom is very dense, having much more mass than volume. The nucleus takes up around 1% of the volume of the atom. Almost all of the atom's volume is taken up by the electron cloud. What do you think? Assumptions for counting subatomic particles. If the number of protons equals the number of electrons, the atom does not have an electrical charge, it is neutral. In other words, the positives and negatives balance out. If there are more protons than electrons, the atom is positively charged. If there are more electrons than protons, the atom is negatively charged. The number of neutrons in an atom does not affect the overall charge of the atom because neutrons have no charge. Suppose a carbon atom has 6 protons and 7 neutrons and is neutrally charged overall. How many electrons are in this atom of carbon? We know that 7 neutrons do not affect the overall charge of the atom. We also know that since the atom is neutral, it must have the same number of protons and electrons. Therefore, we can conclude that this carbon atom has 6 electrons. Reflect. Combining atoms. A pure substance made up of many atoms with the same atomic number is called an element. Atoms can exist by themselves, for example helium gas, or combine to form a molecule with the same type of atom, for example hydrogen gas. Atoms can also combine with different kinds of atoms to form molecules of pure substances called compounds, for example water. Shorthand equations for describing the reactions that form compounds use chemical letter symbols for each element in a molecular formula. Subscripts indicate how many atoms of each element are in the compound. Coefficients show how many molecules are involved. Look out! Names and formulas reveal chemical composition. Compounds are assigned special chemical names, a common name if the substance is well known, and a formula. This information reveals its chemical composition. For example, the substance commonly known as chalk has a chemical name, calcium carbonate, and a formula, CaCO3. The formula, CaCO3, means every molecule of chalk has 1 calcium atom, Ca, 1 carbon atom, C, and 3 oxygen atoms, 0. Reflect. A pure substance is a single substance, either an element or compound, with a definite composition and set of chemical and physical properties. And then we have a table that lists types of pure substances, and an example with a formula and molecular structure. So individual atoms of the same type connect to form extended structure. The example is graphite, which is carbon. Solids made up of 2 atoms of different elements which then connect to form extended crystalline structures. Salt crystal, NaCl. Individual atoms that are not attracted to each other. Helium, He. Molecules of different types of atoms that are not attracted to each other. Carbon dioxide, CO2. Molecules composed of 4 different types of atoms that are attracted to each other to form extended structures. Nylon, C12H22N2O2. Diatomic molecules of the same type of atom that are not attracted to each other. Oxygen gas, O2. Try now. A compound is 2 or more different atoms bonded together. The ratio is important. Just because 2 compounds have the same elements does not mean they are the same substance. Look at the compounds on the side. The one on the left is water. On the right is hydrogen peroxide, the bubbly stuff you apply to cuts. They both have hydrogen and oxygen, but in different ratios. Water has 2 hydrogen atoms and 1 oxygen atom, and hydrogen peroxide has 1 hydrogen per each oxygen. Different models reveal different structural information. There are so many different ways to model a compound. How do these water molecule models compare? Reflect. Crystal structure. The structure of solid matter can either be disordered or ordered. In some types of substances, the molecules or atoms arrange themselves into neat, ordered patterns called a crystalline lattice, which is what causes crystals to form. In other instances, there is no order. In the non-ordered solids, there is no pattern. The atoms are disordered or amorphous. What do you think? Use the table to identify the properties of the subatomic particles. You have proton, neutrons, and electrons. Use the steps below to create a model of a typical neutral atom of lithium. The atomic number is the number of protons. The atomic mass, rounded to the nearest whole number, minus the atomic number equals the number of neutrons. This atom is neutral, so the number of electrons must be equal to the number of protons. Only up to 2 electrons will fit in the first level and up to 8 in the second.